Very cold up here in the Northland. We must consider the emanation or cascading vibration and see what happens when we look into the science of cymatics.
The film you're about to see has no characters, it has no people. It is a film to describe to you and explain visually the effect of cymatic frequencies on texture, structure, water, oil. If you spare a little of your imagination as you watch this film as it runs, you will see many things that answer many questions. You will see living forms, living amoeba, almost animal-like creatures. You will see continents being formed, the earth itself coming into existence, explosions, eruptions, atomic explosions and bombs. You can see all this and watch it before your eyes. But everything owes its existence solely and completely to sound. Sound is the factor which holds it together. Sound is the basis of form and shape. In the beginning was the Word, and the Word was God. We are told that this is how the worlds began and how creation took shape. If we put that into the modern idiom and say that into the great voids of space came a sound and matter took shape. Please watch carefully.
What we see here is the effect of vibration on a specific substance. We use sand and lycopodium. The sand forms the lines. We can also use different shapes of plate. Here we have a triangular plate with a crystal attached to its underside. We change to a higher note and see a rather more complicated figure. But now we can also observe moving waves. Here the sand is flowing in a current. When the wavelengths are short, these currents produce a rotary effect. Areas become defined in which the particles are actually rotating. In vibrating glycerin, we see continuous waves which form the queerest figures. And yet, the extraordinary things we see here are simply and solely the effect of vibration. A fluid, colored black, is dripped into a transparent fluid. Vibration now gives rise to curious eddy formations. Plastic substance is shaped into a ball by the wave trains of the vibrating membrane. The masses are jiggled round, but gradually proper spherical shapes are formed, created by nothing more than the vibratory process. Now, by changing the amplitude, that is, changing the volume of the tone, we can bring about a very interesting phenomenon. The tone is the same, but we introduce a burst, an amplitude burst, and every time we do so, it integrates the whole situation. All materials and substances and the various states of aggregation behave in characteristic ways under the effect of vibration, or we can say that their behavior is specific. Here is a pulp. Here again, round shapes are formed, and circulation is set in motion. There is a definite ripple effect caused by the wave trains in the vibrating membrane, a rich field of effects due to vibration. And, to end with, here, by way of contrast, is a sonorous figure, a static figure instead of a dynamic one, representing the opposite pole in the vast range of phenomena that make up the world of vibration.
Whoa. Cymatics. Who would have thought?
Cymatic music is an ongoing sound, art and science project exploring patterns of vibration. Patterns we can hear, that is to say music, and sonic patterns we can see. Now, how can we see sound? Well, when a physical matter is vibrated with sound, certain geometric symmetries are manifest. And this field of inquiry is called cymatics. Hence the name of this project, Cymatic Music, where my aim is to develop a creative bridge between the basic principles of music and those of cymatic phenomena. Here, a dish of water is vibrated with a low frequency sine wave. As the volume is increased, the circular ripples transform into a dynamic pattern with five-fold symmetry.
Here's where we see a pentagonal. 2, 3, 4, 5. Pentagonal. Remember, in the basic icosahedronic projection, the pentagon is what creates the curvature, or in the soccer ball that we looked at, the essence of buckyballs, nanotechnology.
To appreciate the intricacies of this patterning fully, the footage can be slowed down. And the waveform viewed from above.
What you want to see here is the arcoidal nature of the pentagonal projection, association with this certain frequency. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But the interstice
If the frequency of the sound source is increased, a myriad of different cymatic symmetries can be coaxed from the water. Threefold, fourfold,
1, 2, 3, 4, 10.5 hertz.
twofold,
And you see how it's reflected in the actual patterns that are produced in the fluid.
and fivefold symmetry.
Now fivefold, we start to see this isn't a very good image here. There we go. 1, 2, 3, 4, 5, fivefold, 11.7 hertz.
The progression of these symmetries proceeds in an ordered periodic fashion, as shown in this graph. This wealth of evolving cymatic forms constitutes the source material for a series of short films I've created with the video artist Gregory McNeely.
Well, how many facets here? 1, 2, 3, 4, 5, 6, 7. Septagon.
Like a dish of water, a string can vibrate in distinct periodic modes. These are known as harmonics. The fundamental first harmonic, the second harmonic, third harmonic, fourth harmonic, fifth harmonic, sixth harmonic, seventh harmonic, and eighth harmonic. Each tone an integer multiple of the fundamental frequency. We can map this series onto a grid and add the mathematical inverse, the subharmonic series. The half, the third, the fourth, the fifth, the sixth, the seventh, and the eighth of the fundamental frequency. Each note of this series can in turn be taken as the fundamental of a different harmonic series. The resultant matrix of proportional tones is called a lambdoma and is the cornerstone of a musical architecture called harmonicism. And if we are to find a common language that links music and cymatic phenomena, this seems an appropriate system to adopt. Furthermore, in order to explore the tonality of this different sound world, I've had to design and build some new musical instruments which can be heard in the films I mentioned earlier. The harmonic canon, the harmonic flute, and the harmonic guitar. To what extent, then, does cymatic patterning correlate with proportional harmonicism? Does matter vibrate harmonically? Can we see what we hear? In the case of spherical media, such as bubbles, the answer is yes. The pulsating symmetries of these bubbles directly reflect the rhythmic tones of the harmonic guitar. Other vibrating media show intimations of harmonicity.
You might see the correlation between what you're looking at right here and toroidal energy, or the toroidal rings that we looked at in topic 14, 15.
But at this stage, their musical accompaniment is largely interpretive.
What you want to remember is that there's vorticular energy that's forming this toroidal, so there's actually a circulative pattern within this ring that is making this, keeping it in this confine. But now, rather than just merely magnetism, we're considering the fact that sound is another limiting factor, or shall we say a defining factor. So you see where we have changed the lobal frequency here. 1, 2, 3, 4, 5, 6. So hexagonal in nature, which is more of a dominant, the hexagonal shape, dominant in the icosahedronic projections associated with Buckminster fullerenes, or graphene, nanotubes, nanofibers, nanotubes. Sweet. Beautiful. United Kingdom.
The film you are about to see has no characters. If you spare a little of your imagination, it is a film to describe to you the effect of cymatic frequencies on matter.
So now you're seeing the toroidal or the cyclic indications that we looked at. Vortex energy. Remember the vorticular copper tubing? Start to see how Victor Schoberger and his concepts, vorticular energy. And remember that this is based in the rotation of the Earth, gravity, and geomagnetics. But now we're starting to relate this to actual generated sound.
Everything owes its existence solely and completely to sound.
The Higgs boson particle, the God particle as we called it, the glue that holds everything together, subatomic particles. Is this Tesla or what? So you see where he's projecting a waveform through this pipe, and it's creating a manifestation of the sinusoidal waveform in these flames. Cool how you can see the increase of the amplitude of the waveform then increases the flame length. Whoa, decent. Nikola Tesla, yeah.